Good evening, everybody. John here from Tutor to You. Welcome you along to the first of our 2022-2023 Revision Blast live sessions for A-Level Geography. Massive welcome to you if you're joining live and just having a look down at our clock there. If you are with us live, we'd love to see your responses to any of our questions tonight. Please do use the chat window. If you're watching this on our replay system, welcome to you as well. And of course, you can take your time and pause the video where you see fit to have a think about some of the questions that we've got for you. I'm joined tonight by Alice in the middle of the screen and Brendan on the right hand side. Good evening both.
Good evening everybody.
Hi John.
Just a quick reminder to everybody before we get cracking that if you've not been to one of these before or followed one of these before, as soon as we've finished, the PowerPoint that we're going to use will be available to you to download. And of course, we're recording this, so you'll be able to see a repeat of the video as well. Brendan, do you want to tell us a little bit about what we're covering tonight?
Sure, John, thanks very much. Well, pleasure to be with you all. And this is going to be about AQA A-Level ecosystems under stress. And that's one of the, all the topics are my favourites, but this is possibly one of my special favourites. It's an important topic. It's something to do with, the environment, wildlife, all those kind of issues, and linking with climate change as well. There's plenty of scope for synoptic thinking here, as I'm sure you'd be very pleased to know. So we're going to try and just help you to kind of retrieve some of the things you may already have learned about and maybe kind of make you think a little bit. So, is there anything else we need to add at this point, or should we just get on with the activities?
We'll get started, shall we? Here we go.
Excellent. Right, so if we're going to start off with a bubble quiz, in case you haven't done one of these before, it's a kind of multiple choice activity where any number of the 4 options could be correct, including none of them. So the number of answers that can range from 0 to all 4. So you could have 1 right, 2 right, 3 right, 4 right. So let's see the first question. Which of the following terms is used to describe the variety of flora and fauna within an ecosystem? Remember, it could be any number of answers from 0 to 4. So if you could just put your answers in the chat, and we'll see if anybody is managing to succeed with this one. So one or two, yeah, we've got some good answers there. So let's see what the answer is to that one. The correct answer is biodiversity. So let's go relatively straightforward. Let's have a look at number 2. Which of these terms is associated with the amount of organic material found within an ecosystem? Which of these terms is associated? It could be any one, none of them, or all 4, or any number in between. Have a think. What do you think? You just jot down the letters. Okay, let's see the correct answer for this one. It is 3 of them. It's net primary productivity, biomass, and gross primary productivity are all directly linked with the organic material found within an ecosystem. Thank you. Let's have a look at number 3. Which of these terms is used to describe a major category of habitats dictated by climate factors? A major category of habitats. So jot down your letters. What do we think about this one? Okay, right. And we do have a correct answer, at least one anyway. So let's have a look and see what that... It's all 4. All 4 of these are major categories of habitats. So if you said all 4, you were correct. Let's have a look at number 4, question number 4. Which term best describes the way that flora and fauna in an ecosystem can change over time? It could be 1 or none of these, or 2 or 3 or 4. Concession, succession, secession, or suppression. Jot down what you think is the correct selection here. Okay, and the correct answer is just one of these, which is succession. So succession is when ecosystems change over time, gradually from perhaps bare rock through to a forest. Okay, let's have a look at question number 5. Which of the following best depicts the linear transfer of energy? So read this one carefully. Best depicts the linear transfer of energy from one species to another within an ecosystem. Which of those is the best one to describe the linear transfer? So choose from A, B, C, D. None of them, or any number up to 4. Okay. Good. At least a good choice coming up through there. And the correct answer is food chain and food web. Not to be confused with food system or food mile. You may have studied food miles. That's not really what we're looking for just here. Okay, that's the end of the bubble quiz. We're now on to confusing pairs with Alice.
Thank you, Brendan. Yes, so here we have a different activity. We've got some confusing pairs. So we've got some key terms that you'd be using in your ecosystems topic matched with a definition. But the problem is the terms and definitions may not make sense, or they might make sense. So I want you to look at the key terms in the green box, then look at the definitions next to them on the right-hand side and think about, do they match or not? Are they correctly matched or not? So if you think they're correct, type correct in the chat now. And if you think they need to be switched around, type switch. Just give you a minute to have a think about that. Okay, so we've got input and we've got output. Thinking about natural systems, thinking about that systems concept to help us understand the natural world. Okay, John, would you like to reveal the answer here? Yep, they are correctly matched. So input is the addition of energy or matter coming in from the outside into a system, and an output is energy or matter moving out of the system. That was a nice, easy one to get you started. Let's have a look at number 2. Okay, so within this confusing pair, we have the 2 other key elements of the systems concept which we're using across our physical geography topics. Here we've got flows or transfers, and we've got stores or components. So let's have a look at those definitions next to them and think about whether those definitions make sense, help you understand those key terms. You might write correct in the chat, or write switch if you want them to switch up. And of course, if you're watching this on catch up, you can always pause. But John, let's have the answer. Yeah, they needed to be switched. As people have said in the chat, they needed to be switched. Stores and components are parts of a system where that energy or matter is stored. When we're thinking about ecosystems, it might be within an animal population or within an oak tree. Flows and transfers, it's of course the movement of that energy or matter which links parts of the system. So we're thinking about perhaps the transfer of energy between trophic levels. Number 3. Okay, so we've got key terms, negative feedback and positive feedback. Now that's the other element when we're thinking about a natural system, whether it's in dynamic equilibrium or in fact perhaps there's a more persistent change taking place within the system. So I'll let you read the definitions. So that first one, a change in the system leads to a move away from dynamic equilibrium. And the second one is a change in the system moves it away from dynamic equilibrium, but then back again. Okay, so are they correctly matched or do they need to switch up? Okay, John? So they're correctly matched now. So negative feedback is that change that takes place within a system which triggers knock-on effects, which then check that change and bring the whole system back to a state of dynamic equilibrium. However, positive feedback might be a change. So if we think about in the natural world where you remove a predator, the population of predators perhaps dies out, and that means that the prey are free to breed and multiply, and with more births brings more births, more breeding, more births. And so we've got that positive change and escalation of the population until perhaps the availability of food is something that checks the population and perhaps creates some negative feedback within the population and brings it back down to a sustainable level. Thank you. Number 4, please. So our confusing pairs here are gross primary productivity and net primary productivity. So sounding pretty similar. What's the difference between gross primary productivity and net primary productivity? So here we're thinking about what plants do in an ecosystem, what plants provide within an ecosystem, whether it's land-based or a marine ecosystem. So should those definitions stay where they are, or do they need to be switched? John? Okay, so those are correctly matched. So the difference between gross and net productivity is essentially respiration. So gross is the total energy fixed by plants in an ecosystem by photosynthesis, including the energy that they will then go on to use for respiration, whereas with net, we've taken away that energy that is not going to be available to the consumers because the plants need to respire. Number 5. Okay, so we've got plagioclimax community and climactic climax community. So here, thinking about succession, one of the terms that came up in the bubble quiz, and thinking about the end stage of that change over time of the population of plants and animals within an ecosystem. So which one is truly the end stage and which one represents a state in which human activity has halted that progress? Do these pairs need to be switched up or not? Okay, John, let's have a look. Yeah, we needed to switch them up. So climactic climax community is the final stage of succession when equilibrium has been achieved without external disturbance. So we're thinking the end stage of a lithosphere or a hydrosphere, 2 spheres you need to know about for AQA A-level. Whereas a plagioclimatic community may well be something like a heather moorland in the UK, in a temperate environment where human activity has led to the clearance of deciduous woodland, and it's not been brought back, and that progress to the climactic climax has been halted. Okay, I think we're going back to Brendan now for the connection wall.
Thanks, Alice. And those confusing pairs bring us to sort of consider that some concepts can be quite easily muddled up. So if you didn't catch all that, back afterwards, and Alice made some very good distinctions there between some of those ideas. So, for example, the difference between positive feedback and negative feedback, and the link with dynamic equilibrium. Here we have another really important concept to be dealt with the connection wall. I'll mention that in a moment. So the connection wall is a little bit like something you might see on a particular program on television, which I can't actually mention, but I think it's fairly obvious. And the connection wall contains 16 phrases or terms, and they can be grouped into 4 groups of 4. So you need to look at them, spend some time reading them carefully and trying to spot the connections. Now I'm going to give you a clue, and the clue is that these are all of the groupings are to do with ecosystem services. So can you group these together? If you want to jot them down, the quickest way to do that is you can see there are 4 columns, A, B, C, and D, and there are 4 rows, 1, 2, 3, 4. So, for example, you could put A1 and B1 together with, C4 and D4. I'm not saying they're the right answers, but that's the way you could do it. That's a quick way to jot them down. So I'm going to give you a moment to read through them and see if you can start grouping them together. Off you go. And remember, they're all linked in some way to ecosystem services. That's a very important concept in this particular unit. And use the letters and numbers to make the links. Now, in a moment, we're going to reveal one of the groups, the first group to look at. So let's have a look at that, John. Might help you to find the other ones. So what we have here are 4 provisioning services. Bees produce honey, which we consume. Medicine from rainforests, which we use for our medical care. Sea salt from a place like Tavira in Portugal. Precipitation, we use the water from rain, snow and hail for all kinds of things. Okay, see if you can spot another set of links, another set of services before we move on. Okay, somebody spotted, well done, spotted another link. Let's have a look at the next group. We have regulating services. So these are services where the natural world kind of monitors the environment for us, and it kind of recycles things. So decomposes recycle nutrients. Water is recycled in blanket bogs, and it provides a service to regulate the water supply and the flow of water in rivers. Filtration by soil and rocks, that's a very important service provided where the water is filtered so that we can then use it safely. Carbon sequestration within the ocean floor, very important aspect of what goes on in the ocean with carbon pumps. Okay, let's have a think about 2 more groups. 2 more groups to go. So 2 more, or even 1 more. Right, let's look at the third group. The third group will be supporting services. So, for example, biological weathering by burrowing animals, suitable habitats for flora and fauna, trees absorb carbon dioxide and emit oxygen, and soil formation by bacteria. All of those are supporting services which are kind of underpinning, that are almost like infrastructure within the ecosystems, which leaves 1 more group. Now, before we reveal the connection, take a look at these. You've got Uluru, a sacred sandstone mountain, canopy walkway in the Amazon rainforest, the sacred river Ganges in India, and the right to roam in a national park or open access land. What could possibly connect those as ecosystems? Okay, let's have a look. Somebody did get this earlier, to be fair, so let's have a look and see. Cultural services. So these are another set of things that ecosystems do for us. So ecosystems, it really helps us when we think of ecosystem services, it really helps us to appreciate just what the natural world through ecosystems does for us, and perhaps helps us to appreciate it more and perhaps value it more highly. Thank you very much. Let's move to the next activity, Chains of Analysis with Alice.
Thank you, Brendan. So in a moment, I'm going to ask you to have a look at some statements that we need to rearrange. So this is trying to help you think about how to explain the process of change associated with succession on a hydrosphere in some detail. So there are a few hints and tips, and if you want to take a screen grab of this slide later on or download the slides so that you've got this information, we'll give you the correct answer at the end. So John, let's take a look. Okay, so we've got 5 statements here, or 5 boxes, but we need to rearrange them to complete, if you like, the chain of analysis, because what we've got is we've got numbered cards here, and they've got the name of the stage within the hydrosphere, and then a description of what's taking place within that stage. But as I said, someone's jumbled up these cards. They are not in the correct order. So if we read them through, what I want you to think about is whether you can type the numbers in the chat. So if you think the answer is the reverse, and we've just jumbled them up in reverse, you might write 5, 4, 3, 2, 1. I'll give you a clue, that's not the correct answer though. Okay, so let's have a look at them. The first stage is called rooted plants. Second one says car and woodland stages. We've got the marsh stage. We've got open water. And we've got the swamp stage. So I'm just going to give you a moment to have a look at those cards and read them in detail before we reveal what will be the correct answer. Obviously, if you're watching this on catch up, you can pause the video at this point and have a good think about it. Read it perhaps a little bit more carefully. Think about what will be the start point and what will be the end point on a hydrosphere. As I say, we do need about this particular sphere as well as a lithosphere. So we could get a question about this, whether it be a 4 marker or a 6 marker, where perhaps you've got to use a figure as well, and they've given us a photograph. Imagine how you would explain this process. Okay then, John, could you reveal the answer, and I'll talk this through in detail then. So with a hydrosphere, it's the process by which we go from open water to the woodland stage, which would be our climatic climax community featuring trees. So I think most of you probably realise that we're going to start with 4 and we're going to end with 2, but how do we explain what happens in between? And so here we go from open water, a freshwater body, too deep to sustain plants, has insufficient light available at the bottom of the water for photosynthesis. So there's very few plants that can actually cope with those conditions. Okay, so we'd be looking to algae and those sort of plants to help create some sediment on the bottom for rooted plants. Okay, so rooted plants and some invertebrates and fish would become established at the point where you have plants like lilies that are able to trap some sediment from perhaps the algae that has died and been deposited on the bottom, and that decomposition of sediments and perhaps plant matter will start to increase the substrate and the nutrients at the base. Then we're reaching the swamp stage, where the water is in fact too shallow to support fully submerged plants. We've got many more plants growing here, but less of the submerged plants and more of the plants that need the light, because they've got more light water's not as deep. So those roots continue to trap sediment, creating that sort of proto-soil and rich sediment at the bottom, and taller emergence plants become established like rushes. So we've got here, we've now got a thriving invertebrate and amphibian fauna, and those are again creating sediment and adding fertilizing base. Then we get to the marsh stage, where the marsh floor is rising, if you like, or water is further receding. Other marsh plants establish, trapping even more sediment. Trees are adapted to wet soil with rapid transpiration rate and dry out the marsh. And that brings us to this climatic climax stage, where we've got more air promoting aerobic decomposition. Okay, before we would have had our anaerobic. We've got a flora diversity increase, and we've got those tree species established. So that's how our explanation would go in some detail. Thank you.
Many thanks, Alice. So that's a really important sequence to get into your head about how you get towards succession, and you could apply that kind of idea to almost any ecosystem that you've studied. Okay, let's move on to looking at a key question here. The question is, give at least 2 advantages of using species richness as a way of measuring biodiversity. Now, it says at least 2. We will discuss in a moment more than 2, but we haven't got a lot of time here this afternoon or this evening. So if you could just try and give 2 advantages, first of all, of species richness. Why is that a useful way of measuring biodiversity? So jot down anything you think, just all together briefly in the chat, and we'll see how you get on with that. Give you a moment to do that. So in other words, what are the advantages? Okay, now we are going to provide more than 2, so hopefully you'll have got at least a couple of these. So let's look at the first little group of them there, John. So, right, all of them actually. That's why the balance is tipped. So it's a useful proxy measure for other variations in biodiversity. Now, proxy measure is quite an important concept. We use it quite a lot in geography. We're using one thing which we know is highly correlated with other important things. We may measure it because it's relatively easy to measure, and that point is mentioned in the second batch. Just going back to the top layer, it says it's a useful proxy measure. It can be highly correlated with other measures that are harder to measure, like genetic diversity or ecological diversity. So relatively easy to measure. There's a good, strong evidence base for this over many, many years that is a very sound way of measuring biodiversity. It's quite well understood and widely understood, so that's another reason that it would be quite useful. So therefore, because it's been used for a long time, it's easy to compare over time. If you're looking at longitudinal changes in something, trends in biodiversity, very helpful. Now think of some, next question is to think of some disadvantages. So take a moment to see if you can jot down at least 2 disadvantages of using species richness as a way of measuring biodiversity. Jotting, I've got 1 or 2 good ideas coming in here. Let's just give you a moment longer. So how do your ideas balance up against the ideas we're going to give you now? So the disadvantages include, it doesn't convey the numbers of each species. In other words, the frequency of species. So that's a disadvantage. There's no particular consensus, strangely, about the definition of what a species is. So that could be an issue. And some species are very closely related that might be counted separately, whereas others are very different. So is it giving enough weight to the variations that you get between one species and another? And one of the issues that we can consider here on this, you could imagine a question might be something like, to what extent is species richness a useful way of biodiversity? With this, you often will have to come up with some sense of balance. We're showing them as balanced, but are they really balanced? Are the points on the right and the points on the left of equal weight? That's the kind of thing you have to consider. And I might also add that you could alternatively consider the Living Planet Index as a different way of doing this, because this provides information on changes in the world's vertebrates and provides guidance on habitats or ecosystems where species are declining most rapidly. So this is not the only way of measuring biodiversity. So the Living Planet Index, it can help identify human impacts, anthropogenic impacts, and help us to focus on and manage biodiversity loss. So that's a question of balance. And we're now going to, case study time, I think. The siren's gone off.
Yeah.
Over to you, Alice.
Thank you, Brendan. This siren reminds us that we do have some case studies associated with ecosystems under stress, and we'll be looking at some of them in this session and the next session on ecosystems. Here, this alert is just reminding you that you have an ecosystem at a local scale. Now, here at Tutor to You, our local scale case study is the Wyre Forest in Worcestershire in central England, but no doubt you will have studied something different, and that doesn't matter. You just need to know what that case study is, and you need to know stuff about it. So you need to know things about the nature and the properties of that ecosystem. You need to know how humans have changed it, and also the opportunities and threats associated with its sustainable development and management today. So just a reminder there that we have some specific case studies for ecosystems which could come up in your longer answer questions. Here we've got a wood warbler in our temperate deciduous forest, snacking on an insect and generally demonstrating the food chain there. Okay, so let's have a look at an activity linked to your local scale ecosystem. You're going to have 90 seconds, I believe, to answer 3 questions. John will no doubt help us through it. So you're going to have 90 seconds to answer these 3 questions. And if you've got pen and paper and you're watching on catch up, of course, you can pause the video. But what I'm asking you for is I'd like 3 properties of your local scale ecosystem. So that's the first thing, and I need 3 of them. The second thing is I want 2 human impacts upon it. So think about what human activities have shaped and changed that ecosystem. And I need 1 challenge or opportunity linked to its sustainable development. So feel free to drop us a note as to what the case study is in the chat if you want, and perhaps your 1 opportunity, that might be a good thing we can get in the chat. And the rest of us, let's try and use pen and paper and jot these things down. You've got 90 seconds.
5, 4, 3, 2, 1.
Okay, so that's our 90 seconds up, I take it, John. Is that right? So how did you get on? I think that was quite tight for some people, whereas other people jotted things down quite quickly. Perhaps you've done a bit more revision of this topic recently, or you've only just done it with your teacher. There was a comment in the chat, can we use the same case study that we've used at GCSE? I doubt the detail will be there, but it might be a jumping off point to look into your case study in a bit more detail. Talk to your teacher about whether you're going to do the same or a different case study at A level. Okay, so let's have a look at the Wyre Forest answer we've got here, John. So properties of this ecosystem. So we're thinking about what type of ecosystem is it? How does it work? Here we've got a broadleaf temperate forest in the Wyre Forest in Worcestershire. We've got the scale of it. So we've got what biome is it associated with? We've got the scale of it. Well, it's 1,750 hectares and it's been designated as a site of special scientific interest. There'll be some overlap with other people's local ecosystem, I think there. Is your place a triple SI? Worth mentioning, perhaps, in terms of the diverse nature of habitats. Thirdly, there are some key bioindicators in the Wyre Forest in terms of indicating how diverse it is and how perhaps important it is as an ecosystem to protect. And those are the fritillary butterfly, for example, and some rare migrant birds like the nightjar. So these are we're just getting into sort of detail. I appreciate it's not your case study you've done with your teacher, but I'm demonstrating the level of detail you might need to bring across when you're having to write about your case study. So for we were after 2 human impacts on it. And in the Wyre Forest, we've got selective deforestation, which took place in the 18th century, specifically for the coal industry that needed the timber. But more recently, we've got the activity of halo thinning, which is a form of management within the woodland to encourage tree seedlings to mature into those mature oaks, for example, that support so many different plant animals and create all those ecological niches. And then the last thing you were asked for was a challenge or opportunity linked to its sustainable development. Here I've cheated a bit. I've given you more than 2 for each of them. So O is opportunities. More tourists are being taken into the Wyre Forest and it's creating some honey spots are being created for tourists. But we've also got some woodland enterprise to actually coppice and sell the wood, which is taking off. We've also got the threats of Dutch elm disease affecting the elm trees in this woodland, the management of bracken, which is being managed with cattle because they don't want to overtake all those tree seedlings. And of course, the woodland is having to adapt as a ecological community to the challenges of climate change. Okay, I think we're off to Brendan, who's got some multi-choice questions for us and some wonderful holiday snaps. Is that right, Brendan?
There could be a few holiday snaps in there, Alice. Thank you very much. That was great. Okay, so one of the things that you have to, we're trying to make sure that you are studying ecosystems under stress and that you are not going to be students under stress. So hopefully this is helping you. And we're going to finish off with a round of multiple choice questions, which will be relatively easy for you to give the answers to, but more challenging to think about. So one of the things we're always trying to get you to do as young geographers is make sure that when you see a landscape and you experience a landscape, you can start to describe it and explain it and understand what's going on and analyse it and so forth. So one of the things that happens in the exam is you will often be presented with images of places that you've never seen before. You're presented with novel situations to consider. So question 1 in this case is an image of some mountains in Waterford in Ireland, beautiful part of the world. You can just about see a sheep staring at me as I was taking this photograph because very few people go to this area and I think he felt I was some sort of space invader. But anyway, the question is, in this upland ecosystem, which list of things describes only biotic components? Is it A, grass, lichen and humidity, B, high rocks, water and sunlight, C, grass, sheep and lichen, D, high rocks, water and sheep? Only one of these answers is correct. This is not the bubble quiz. There's only one that's correct here. What do you think it is? Well done, Melanie. I think that's the right answer. Let's have a look. C is the correct answer. Excellent. Okay, let's look at question 2. This photograph is taken of actually a plesioclimax community in the North Downs, Chalk Downlands, and this is a very managed landscape. Anyway, in a chalk downland terrestrial ecosystem, which of the following describes only abiotic components? Is it A, cattle, grass and trees, B, scarp slopes and infertile soils, C, scarp slopes and crops, and D, infertile soils and cattle? So which of those is the correct answer? Got a couple of various answers here. So let's have a look and see what... Yeah, B is the correct answer. Scarp slopes, the chalk itself, and the infertile soils would count as abiotic components. All the others have something that's biotic in them. Let's look at question 3. Question 3. Which of these images shows a local lithosphere? Now, in this case, we're going to be using the kind of academic words we use to describe different ecosystems. So you need to know those. Let's have a look and see what these could be. Well, you've got sand dunes, salt marsh, freshwater pond, or glaciated mountains. The choice is A, B, C, and D. So which of them could be described as a lithosphere? Which letter would be the correct one? Right. Well done if you said A, glaciated mountains. And one of the things about words like this is it's always very good to consider the etymology of the word, where the word came from. And sometimes these words are based on Greek things, Greek words. So litho is to do with rocks. So that's the one there. Let's look at question 4. Question 4, which of these images, the same set of images, by the way, shows a local hydrosphere? So look at the word and make your choice. Is it A, B, C, or D? Well done. Yeah. So well done. Good answer there. Freshwater pond, because hydro gives the game away there because it's to do with water. Not completely clear though, because one of the others is to do with water at least, or they've got water in them. So, but it's the one that's principally about a watery sort of ecosystem. Right, number 5. Which of these images shows a local halosphere? Is it sand dunes, salt marsh, glaciated mountains, or freshwater pond? And once again, I'd recommend that you consider the etymology. So the correct answer here is salt marsh, because halo is the prefix, again, I think from the Greek, to do with salt. Right, number 6. And final one, well, kind of by process of elimination, really. Which one have we not chosen so far? So it should be fairly straightforward. So number 6, the answer is sand dunes. We seem to have 2. There's a little error with that one. One of them should still say one of the other answers. But anyway, sand dunes, because samo is pertaining to salt. Let's have a look at number 7. In a samosphere transect, which term applies to different points of development, such as the strand line, embryo dunes, and mobile dunes? And this photo, by the way, is a wonderful place to see sand dunes at Rossbank Sands, and you can see Lindisfarne in the background. Okay, so which term applies to the different points of development? And you can see them there from right to left: strand line, embryo dunes, and mobile dunes. Okay, right, some good answers there. So yes, indeed, it is cirral stages in a samosphere. Okay, next question, number 8. This is actually an area of sand dunes, believe it or not, called Cenfig Sands in Wales. Beautiful part of the world. So in a Samosear transect, so a sand dune environment where you're walking or taking a transect across it, which term best describes an area inland, this is away from the sea, where the scrub and woodland has become really well established? Is it A, climatic climax community, B, woodland community, C, successful community, or D, scrubland community? Make your choices. And if you were listening earlier on, you'd probably be able to pick up on this one. Greatly well done. Yes. A, climatic climax community. This is what you will see in a sand dune environment. It's the bit that people perhaps don't notice so much, but you as a geographer can put them right on that. You would notice that. Number 9. This is the number pyramid for an ecosystem. What term is used when the quantity of organic matter is taken into account rather than the numbers of, for example, the total large carnivores, etc. There's A, pyramid of population, B, pyramid of weight, C, pyramid of biomass, or D, pyramid of Giza. Just a hint there, one of those answers is what you call a silly answer. So don't choose the silly answer. I mean a really silly answer. Okay, let's have a look at the correct answer, the most non-silly answer. It's pyramid of biomass. Not to be confused with the pyramids of Giza, which are in Egypt. Totally different thing altogether. And the final question, number 10, is there's a common kestrel that's just caught a mouse. And what we want to know is, in a food chain, what term is used to describe a carnivore such as a kestrel, which you would find in trophic level 4 or 5? Is it A, an apex herbivore, B, an apex predator, C, an apex producer, D, an apex heterotroph? Go on, get this one right. It's the last question. Well done, some of you. Yep, okay. If you've got B, that's correct. It's the apex predator. Okay, so marvellous work. Well done, everybody. And Alice is just going to round off with a couple of comments for the evening.
Yeah, I was just going to say that we've got a couple of resources on Tutor2U which people might want to check out. One hasn't been yet. It's Ecosystems Part 2, and that's going to take place on Thursday, the 3rd of November. So we're having a bit of a break for the half-term holiday. So back on Thursday, the 3rd of November, to find out about ecosystems under stress. Part 2, it's going to be 6:30 again, so do join us for that. And then there's a hyperlink there with a link for a teacher resource from the Tutor2U website. Clearly, when we look at the second half of the topic, we're going to get into some of those other case studies and key ecosystems and biomes, should I say, that you need to know about, which include the savannah. And I believe that one isn't a holiday shot, is it, Brendan?
No, I haven't actually been lucky enough to go there yet. So that looks like that must be one of yours, I think.
Well, no, it should be, really. I had a very memorable trip to the Ngorongoro crater in Tanzania many moons ago. But yeah, maybe we can bring that up next time.
And what about the Pyramid of Giza, Brendan? Have you been there?
I haven't, but I've flown over it. I've seen it from a great distance, from a great height.
Yeah. So some good puns from Brendan there, and I think next session we can guarantee more puns and silly answers.
Excellent stuff. I'm going to give a shout out to Melanie, who I think has answered more questions than I've ever seen in a live stream before. So big thank you to Melanie, and of course a massive thank you to both Brendan and to Alice for putting this together today and delivering that. Fantastic. I learnt an awful lot from that. Wonderful stuff. So Alice, you said we're back in a couple of weeks, aren't we? We've got a bit of a break for
Thursday,
the half
the 3rd
term
of November.
But we'll be back for some more ecosystems under stress.
Absolutely, and thank you to everyone that took part. But good luck with your revision.
Yeah,
thank
absolutely.
you. Thanks a lot.
All the best, everybody.
And just a quick reminder, of course, I should say, just to remind you that the PowerPoint will be available in just a few minutes' time. So if you want to look through that again, you can do. Goodbye from me, goodbye from Alice, and goodbye from Brendan, and we'll see you all very soon.
Bye. See ya.
Bye. All the best.